Good morning, students. My name is Abhishek Sachdeva. I am from Lalpur Khalsa College of Engineering, Department of Civil Engineering, and this is the lecture for Civil fourth semester class, and the subject is Concrete Technology. So, students, in the previous video, we have discussed the example of design of M40 grade of concrete and the general structure of the mixed design. Various steps were involved in the mixed design, and we have discussed the step by taking the example of M20 grade of concrete. So in continuation to that, today also we will be discussing a design of M40 grade of concrete as per the design considerations which are given in the code IS 10262 2009. So basic structure of the mixed design steps involved in the mixed design that we have discussed earlier. Now, considering the detailed consideration of IS 10262 2009, we will design M40 grade of concrete and we will consider all the minute parameters which are included in the mixed design of the concrete. So students, this was the step-by-step procedure for the mixed design. The steps remain the same, design procedure is same, elements are same, but we will be considering some of the minute parameters in the design of M40 grade of concrete, and this M40 design of the concrete, it is taken from IS 10262 2009. You can refer the last pages of the IS code which has given us the detail of the design of M40 grade of concrete without the fly ash or without adding any admixture, and the B portion will be the inclusion of the fly ash with inclusion of the cement content. So we will be discussing the problem for the M40 grade of concrete. This is the example which is given in your IS code IS 10262. So example illustrating the mixed proportioning for a concrete of M40 grade, which is given from A1 to A11 of your IS code. So this is the data which is available. As I have earlier also told you, we are in the requirement of the specific data for mixed design. So considering this data, we will design M40 grade of concrete, and we will be taking into the consideration the super plasticizer also, which we have not considered in the earlier example, and the data includes the design of M40 grade of concrete. The type of cement is OPC 43 grade, and the maximum nominal size again it is 20 mm with the minimum cement content value of 320 kg per meter cube, and the water cement ratio is 0.45. Workability, now workability, it is considered over here as 100 mm slump value. So in the previous example we have considered the workability in the range of 50 to 75 mm, and now the workability required is the 100 mm. So we will be designing the concrete to obtain the 100 mm slump value. Now students, this particular workability, it is important element, because whenever we are going for the mixed design, we initially weigh the ingredients. For example, we are weighing the cement, we are weighing the admixture, or we are weighing the quantities of the fine and the coarse aggregates, and we are deciding one water component. We are adding that water component, and then we are mixing the all the ingredients. Students, before production of the concrete or before filling up the concrete cubes, we perform this workability test. And this workability, if the required workability as per the statement is 100 mm. So when we are performing the slump test before filling up the cubes, the workability should be 100 mm. If we are not getting the required workability as per our requirement, then we need to work out the ingredients again. We need to add the super plasticizer, we need to increase the water content. Number of parameters are there to adjust the workability. So this workability is very important parameter, and we should be able to attain the required workability after mixing the various ingredients and before filling up the concrete cubes for the curing. So workability we need to attain is 100 mm for this particular question. Exposure condition is given, that is severe, and for reinforced concrete we are designing. Method of concrete placing is pumping. This is also one of the parameter which we have not taken into the consideration in the previous question. Then degree of supervision, it is good. Type of aggregate, crushed angular aggregate, and maximum cement content is 450 kg per meter cube, and the chemical admixture type which is used in this particular example, it is the super plasticizer. So students, basically why I am focusing on this required parameters, because we will follow IS 10262 guidelines considering all these parameters in detail, and we will be calculating our quantity for the ingredients of concrete. So we will consider in particular pumping parameter, workability parameter, type of aggregate, it is the crushed angular aggregates, chemical admixture type, superplast as a type is used, what is the effect of this given particular data which I am highlighting on the mixed design procedure. I will show you as per the guidelines given in IS 10262 2009. So in the previous question we have discussed the general structure of design. In this question we will be discussing each and every detail in very minute form as per the guidelines given in the IS 10262 2009. So students, test data for material, as we are going for the design mix, we need to have the testing on the various materials. We need the data, testing data which is given to us, that is the specific gravity of the cement 3.15 which will be used in the mass calculations, specific gravity of the coarse aggregate, then fine aggregate is given 2.74, then water absorption of the coarse aggregate and the fine aggregate is given. So this particular data is required while calculating the mass for the various ingredients of the concrete as discussed in the previous lecture. So starting with the mixed design part, step by step we will proceed as we have discussed in the previous lecture. First is the calculation of the target mean strength, and F-CK is denoted as the target average compressive strength at 28 days of the curing, and it will be equal to the characteristics compressive strength at 28 days plus 1.65 into the standard deviation. So as it is same as we have discussed earlier, table 1 will give us the value for the standard deviation. This is the target strength for mixed proportioning 3.2 clause of IS 10262 2009. So FCK F dash CK equal to FCK plus 1.65s, and we are going to design M40 grade of concrete for which the assumed standard deviation will be 5 Newton per mm square. Now students, 5 we will take the value as S, and you can see the note below. The above value correspond to the site control having proper storage of the cement, weigh batching of all materials, controlled addition of water, regular checking of all materials, aggregate grading and moisture content, and the periodical checking of the workability and strength. So these factors, if they are being taken into the consideration at site, then we will drive this particular assumed standard deviation values but where there is a deviation from the above, if these above factors they are not taken into the consideration at the particular site of work, then the values given in the above table shall be increased by 1 Newton per mm square. So this factor you need to take it into the consideration. If the proper checks are there, the controlled conditions are available at the site as mentioned in the factors, the value it will be standing as 3.5, 4 and 5 only. But if the factors they are not taking into the consideration at the site, then the values it can be increased by 1 Newton per mm square. So this is the table 1 of IS 10262 code. So students, so we will take the value of S as 5 for this question, and the target strength it will be 48.25 Newton per mm square. So our characteristics compressive strength was 40 and the target strength it will be 48.25 Newton per mm square. That means when we are going to test the concrete cube after 28 days of curing, the value should be 48.25 Newton per mm square. If the value is not this target strength value, then we have to test the cube again, or we need to design the concrete again. So we need to achieve our target strength of the concrete at 28 days of the curing period. Next is the selection of water cement ratio. So selection of water cement ratio will be taken from the table 5 of IS 456. Maximum water cement ratio is 0.45. So table 5 of IS 456 we will refer. You can see this table. This is the table 5, and we are having in this statement the severe conditions. So for severe condition for reinforced concrete structures and the nominal size of 20 aggregate, the value is 0.45. So that means the maximum free water cement ratio it should be 0.45. This was mentioned in the statement also. So if either it is not mentioned in the statement, we will get the value from table 5 of IS 456. And so students, you can say this based on experience, adopt water cement ratio as 0.45. So maximum water cement ratio was 0.45. So based upon the experience or the while referring to the other mixed designs, so we can adopt the value of the water cement ratio as 0.40, 0.40. So hence 0.40 it is less than 0.45, hence it is okay. So basically why we have not taken the 0.45 value and we have taken 0.40 only. So students, you can take 0.45 also. There is no issue, but we cannot exceed the value from 0.45. Definitely we need to keep this value below this 0.45 value. So that's why we have taken 0.40. You can take 0.42 also, 0.38 also. But this particular value or the this selection of the water cement ratio, this will be modified if we are not getting the desired workability of the 100 we should be getting the 100 slump. If we are not getting the 100 slump, then we can change this water cement ratio also. We can go with the 0.45 value also. So but on the same time, if we reduce the water cement ratio, definitely it will be increasing our compressive strength. If we reduce the water cement ratio, our strength also increases. But reducing the water cement ratio below the slump value also reduce. So we need to balance these two parameters, and for balancing these parameters from based upon the past experience, we have taken the water cement ratio as 0.40. So selection of water content. Now this is the next step, selection of the water content. So from table 2, maximum water content is 186 liters for 25 to 50 slump range. So students, you need to know this particular clause which was not taken into the consideration in the previous lecture, because the design of M20 grade of concrete, what we have done previously, it was for the slump of 50 mm around. So now what is this clause? From table 2, maximum water content is 186 liters. In bracket you can see for 25 to 50 mm slump range, and estimated water content for 100 mm slump value is 6%. We have increased this value. Initially, the water content which was taken from table 2, that is 186 liters, but we have increased 6% because our slump value, it is 100 mm slump value is required, and this 86 liter is for 25 to 50 mm slump range. Now from where we have taken this values, from where we have taken this parameter, from where we have increased this 6%, I'll explain you in detail. You see this is the table 2. Maximum water content per cubic meter of concrete for normal maximum size of aggregate. We were having the 20 mm as the maximum size of aggregate. So water content is 186 liters, that is 186 kg. But this value is for 25 to 50 mm slump, and why it is for 25 to 50 mm slump, why we are considering this parameter, because it is given in the IS 10262. You can see this clause 4.2. A5 and B5 are the examples which are mentioned after the IS code. So clause 4.2, you can see this 4.1, 4.2, actually what it states, if you go through these particular lines for the desired workability, you can start from here. The quantity of maximum mixing water per unit volume of concrete may be determined from table 2. As we are referring the table 2, the water content in table 2 is for angular coarse aggregate and for 25 to 50 mm slump range. Now students, this is given in page 2 of IS 10262. The water content in table 2, it is basically for the angular coarse aggregate and for 25 to 50 mm slump range. The water estimate in table 2 can be reduced by approximately 10 kg for sub-angular aggregates, 20 kg for gravel with some crushed particles, and 25 kg for rounded gravel to produce same workability. So depending upon the shape of the aggregate, the value will be reduced. If the aggregates, they are rounded in nature, that means they are rounded aggregates and they are not having any interparticle friction between them, so that's why the workability, it can be decreased up to sorry, the water content, it can be decreased up to 25 kgs. So this is the one parameter which is the shape of the aggregate. Then for desired workability other than 25 to 50 mm slump range, as in the question we are having the desired workability of 100 mm, and the 186 kg or 186 liter, it is for 25 to 50 mm slump, then what we have to do, the required water content may be established by trial or can increase by about 3% of every additional 25 mm slump, right? So you need to be particular for this statement, that is the required water content may be established by an increase of about 3% for every additional 25 mm slump. We are having the slump value of 50. Considering the slump value of 50 mm, the water content is 186 liters. But now the desired slump value is 100 mm. That means we need to increase 3% for every increase in 25 mm slump. So from 50 we need to go to 100. That means from 50 to 75, 125 mm. For that 25 mm, 3% will be added, and from 75 to 100 mm slump, again 3% it will be increased. So total 3 plus 3, it is 6% increase. If we need the required workability of 100 mm slump, we need to increase the water content 3%. So that we have done over here. You can see 6% of 186 liters has been increased, and the estimated water content for 100 mm slump is 197 liters. So this is the estimated water content for 100 mm slump value, 197 liters. So now again, as super plasticizer is used, the water content can be reduced up to 20% and above. So from where we have taken this particular statement, as super plasticizer is used, the water content can be reduced up to 20% and above. So based upon the trials, this, with super plasticizer, water content reduction of 29% has been achieved. Hence, 29% decrease. By considering this 29% decrease, the final water content which has been taken into the consideration for this design of M40 grade of concrete is 140 liters. So students, this particular content, it again, it has been taken from this particular portion only. You can see this water reducing admixtures or super plasticizing admixtures usually decrease water content by 5 to 10% and 20% and above respectively at approximate dosages. So students, for if the question includes the water reducing admixtures, then we can reduce the water content up to 5 to 10%. And if the super plasticizer admixture is used as we have used in this particular question, it can be reduced up to 20% and above. So considering this particular parameter, as super plasticizer is used in the question, so we can decrease the water content by 20% or above. So taking the past experiences, so we have reduced the water content by 29%. Again, this particular parameter can be changed depending upon the workability, right? When we are going to perform the slump value, if we are not getting the desired slump value, so we can definitely change this particular content as it is based upon the trials. So for now, what we are doing, we have achieved the value 197 liters. Considering that particular parameters which were discussed in the clause, we are reducing the water content by 29% and in accordance to the clause, and the required water content, it is 140 liters. So this was the selection of the water content. So target mean strength, selection of the water cement ratio, selection of the water content in accordance to the clause which were available in the IS 10262. We have considered all the clause or the all the parameters, and we have derived these quantities. So students, each and every parameter you need to study thoroughly in the IS codes, right? So further, the next step will be the calculation of the cement content. So we will continue this particular lecture in the next video. So keep associated with this content because it is very essential part, as we are following each and every guidelines which are given in the IS 10262 2009. Thank you.